Gaetano, thank you very much indeed. I think this mic is working. My lapel mic, I think, is not working, but I hope this one is. And it's a great pleasure and privilege to be starting off the first session. And I'd like to ask the panel, if I may, to come up, and we'll then get the proceedings underway. And many congratulations, Gaetano, on this fourth conference. And I must say, what fantastic surroundings to have it in. And first of all, for this session, which is entitled Dreams, Principles and Regulation of AI, and I have a particular soft spot for this area because my select committee is going to be reporting in a week and a half's time. So I've been living, eating and breathing AI for the last 9 months. But it's a great pleasure to introduce Dr. Kim Voll, who's a senior technical designer at Riot Games, and she's going to talk about thinking machines today, the limits, the possibilities and the dreams of AI. Okay. And thank you very much for being so valiant in coming today, crutches and all.
Thank you very much. So everyone's probably wondered, I tore my calf, that's why I'm on crutches, but it's all okay. Getting better. I just have to hobble around a little bit. So thank you so much. I was here last year speaking about VR, which was a ton of fun, and I'm super excited to be back in one of my absolute favorite areas, AI. So today I am a technical designer at Riot, which means I both program and I design. I have a PhD in computer science, specializing in artificial intelligence, and I've had a lifelong love of AI. When I was little, I started writing chatbots on my old TI-99/4A, for those of you that remember that. I later tuned into text adventure games and creating those, and that's led to all the way today, where at Riot Games I do a lot of things, but one of the big areas is leading up player behavior. So I do a lot of work in machine learning today, processing tons of text and whatnot, and a lot of AI-adjacent work understanding player behavior. So today I'm going to talk about a few things, but I'm going to give a really quick history. So my hope is to sort of set up a little bit of the lay of the land. This is going to be a hyper-abridged edition because it's huge and there's a ton of stuff I could go on at length for, but I'm just going to try to cram this all into a quick 20-minute overview. So I'll give you a little bit of history. We'll talk about what AI is and kind of frame some of these definitions because there's a lot of terms being thrown around today with great vigor, some of which are being thrown around rather incorrectly, so we'll try to clarify some of that. Lay out a little bit of the state of the world, and we'll dig into a lot more of that through the next 2 days or so. And then I want to throw a few challenges, questions, things to think about over the next 2 days, themes that will keep reoccurring throughout the talks, but also hopefully things that you will take away in this space and continue to ruminate on going forward. Okay, so I'm going to try to cram a little bit of history from 4000 BC to now. It's going to be really brief. So this whole concept of artificial intelligences and agents has been around for an incredibly long time. Many, many hundreds of years we've been talking about aspects of this, but even thousands of years before that, ancient Greeks had myths about these robots or early automatons, and even early Chinese and Egyptians were building these automated entities or talking about theoretical automated entities, et cetera. And so the earliest concepts that we actually would attribute to artificial intelligence, potentially, if you're looking at it through a semi-liberal lens, would be actually classical philosophers who attempted to describe human-like thinking as the processing of symbols. So fast forward slightly to 1950, and Alan Turing, who's a name many of us know, of the Turing test being a famous aspect of artificial intelligence, which for a long time was seen as the, roughly speaking, gold standard for how you might assess the efficacy of artificial intelligence through the lens of human intelligence. And this was essentially assessing a machine's ability to exhibit human-like intelligence through a text-based interface. So you would have a human evaluator, they would go into a room, they would not be able to see another person nor the artificial intelligence, which would be in separate rooms as well. So you have this three-way trifecta, and the evaluator would then be able to hold a conversation with both the other person and the AI, and they would not be told ahead of time which is which. So being able to determine which one would be artificial or whether or not they're both come across as human, there's a lot of different variants of it, but that's kind of the idea. So it kind of bundles up AI into this notion of behaving externally like a human is a test for having human-like intelligence. So it has its limitations in that it's very externally focused. But the actual genesis of modern AI was around 1956. There was a conference when Marvin Minsky, who coined the term, had a whole bunch of great minds in and around cognitive science come together to talk about these issues. This led to a lot of really, really grandiose claims, slightly efficacy. But they had these really big claims. They were like, by 1967, we will have solved chess and done all of these wonderful things with artificial intelligence. We will have human-like intelligences, in a decade or two, give or take, which of course didn't happen and led to what they call the long winter of AI. So from roughly the mid-1970s until the 90s, and the 90s was when I started university, when I started studying this stuff, basically you were shunned if you were looking at AI in any real way. There was very difficult to get funding. As a new university student, I was fascinated by AI, and I'm like, I'm going to do AI. And my professor was like, no, you're not. Why not? And so there was a lot of, even things like machine translation, which today is at a very mature level, it was thought to be theoretically impossible for many folks. So fast forward now, 1997, we actually see the world champion Garry Kasparov in chess fall to an AI. So it did finally happen, but 30 years after the initial estimates. But this actually reinvigorated the field, and you see a lot of stuff happening here, which I'm just going to skip right over, but I'll hit a few moments. So 2011, we had the Watson, IBM Watson, which beat two folks, Ken Jennings and Brad Ruttner, at Jeopardy, pardon me. Watson was the one that won the $1 million prize in this contest. 2015, we had a bunch of work being done around free-form games using Google DeepMind. So they actually were able to defeat or solve a number of Atari games. That is to say, either complete the levels or get the highest theoretical score. We saw more of that in 2016 when some work by a company called Maluba that was acquired by Microsoft, they were actually able to get the highest theoretical score in Miss Pac-Man and Atari. Go, which was sort of considered the final frontier when it came to solving games, in March of 2016, the AlphaGo system, developed by, again, the Google DeepMind team, was able to defeat one of the world's greatest Go players. And then in 2017, just this past fall, the AlphaGo Zero beat AlphaGo. So again, where we thought Go was theoretically impossible, we are now cresting even those goals. We've had huge advances since 2016 in object detection. We're now at a world where artificial intelligence or systems in this space are less than 3% errors, whereas humans are around 5%. And so this has led to things like being able to detect skin cancer at a rate that is basically on the same level or exceeds what dermatologists can do today. And finally, I'll just mention that speech recognition has advanced to the point where we can actually, as far as switchboard operators are concerned, Microsoft and IBM have both achieved performance now within close range of humans. So we've really started to knock down what were thought of as some of the final bastions of technological hurdles that we were facing. And we're moving into a world where AI is becoming a household name. It's no longer an esoteric research field. It's no longer something that you need to sort of hide if you're working in this area, which, as I say, for the first portion of my research as a university student, that was certainly the case. Today, it's talked about by basically everyone. So let's talk a little bit more about what it is. So depending upon your lens, AI can be many different things. It can be a tool to increase human efficiency. It can be a model of human behavior, a lens through which we can better understand ourselves. It can be the evolution of humanity. It's often framed as this is what happens post-humanity. This is how we're evolving today. It can be a simple curiosity. But the term itself, unfortunately, is overloaded. So there's many ways today that it's being used in common parlance. It can be the end goal, what we're working toward. It can be the approach that we're taking. It can be the individual tools or products that we're using, or the learning algorithms that we're generating. It can be a field of study, a marketing ploy, very common today. It can be just an underlying philosophy of how we think about the world and human intelligence. It can just be a commentary on the state of intelligent technology, and many, many more things. But kind of true AI, if you were to call it that, is really a system that performs tasks in a human intelligence-like way. with the potential to exceed human intelligence. So it can learn, can iterate, and theoretically, at some point in the future, it can be self-aware. We're still pretty far from that world. Today's AI is usually more in the realm of pseudo-AI. It's really more like the building blocks that will eventually unlock that future, and we don't have a good calibration of how close that future is or the theoretical possibilities of that future. One of the ways in which we divvy up the space is talking about AI from the perspective of narrow versus general. So narrow AI, sometimes called applied AI, is non-sentient machine intelligence. It's typically focused on a narrow task, something that that system is good at. It can, do your taxes, it can play a chess game, it can play a game of Go, etc. But if you were to cross those things, that AI would not be capable in those spaces. What we're starting to see today is actually amalgamations of multiple or applied AIs that can do a few different things by including multiple AIs. But we're really not seeing what we call general AI. So this is sometimes called artificial general intelligence. It's still mostly in the hypothetical range. So this is a machine or technology with the ability to apply intelligence to any problem. So it's able to generalize across multiple problem spaces. So it's not dealing with a predefined or specific set of problems. And it's thought of being at least as smart as a typical human being. This is where we map into superintelligence. So this is where a lot of the big, scary concepts or the huge possibility spaces sit with AI. So this is where we move into AI far surpassing the skills of the most gifted human minds. So we're mostly here today. So one way we can look at AI is actually through the levels of how it works and what it processes. So today, most consumer AI is around what we call reactive AI. So this is essentially systems that do exactly what we tell them to do, or exactly what we program them to do. There's not much engagement beyond what their scripted behavior is, but they're consistent and their behavior is reliable. If you give input X, you get Y out pretty consistently, if not completely consistently. The goal here is to increase human efficiency or augment human capabilities. There's no real historical record or recollection mechanism, so they're not really necessarily learning and carrying forward information in really any practical applied way. However, limited memory AI is where we're starting to explore now. So these have some degree of process memory. There's no theory of mind, if you will. They can learn and change, and their behavior may be inconsistent, so they're not necessarily deterministic. So this would be an example of Tesla's self-driving cars. Theory of mind AI, though, can form representations about the world. So this is the ability to recognize and represent other entities' intentions and motivations. So I can look out at the world and draw conclusions about what I think is going on with each of you, for example. It has the ability then to start evolving toward social capabilities, which if you look historically at human society, that was actually the genesis, is the ability to form these ideas around what other people were thinking and use that to drive social interaction. And it's dynamically adjusting. So Google's self-driving cars, you'll notice I've got self-driving cars twice here, are actually trying to do that. They're trying to create a more comprehensive representation of the world, this greater interconnectivity, in order to create more intelligent systems. Whereas Teslas are a little bit more assistant-like, and they're probably working in this space as well, but as far as the stuff in market today. Then when we get to the superintelligence aspect, this is where we're dealing with self-awareness. These are the things that Hollywood loves to share with us, the HALs, the Skynets, the matrices. So these are all of the above, plus the ability to form representations of self-internal states. So you can reason about what you're thinking, your state, etc. This is sometimes where we see the singularity referenced. So machine learning is a term that's being bandied about considerably today. This is actually a field of computer science. It's a subfield of AI. And it's differentiated from the traditional symbolic methods where we thought of things as more like traditional computers with inputs and outputs. Machine learning is more of a distributed way to look at the world. So this is the mechanism for learning new things without explicit human intervention. There's two really important breakthroughs that led to machine learning driving AI so heavily today, as it's one of the key mechanisms. The first was the realization, actually, a very long time ago. So Arthur Samuel, back in 1959, he was a machine learning pioneer, also a pioneer in gaming as well. voiced the opinion that it probably didn't make a lot of sense for us to teach computers everything, which was what the symbolic methods were essentially saying. If you could model the whole world and cram it into a computer, then a computer could reason. But rather to teach them to learn, you know, the whole teach a person to fish. So that kind of mentality way back when was the first shift in thinking for how we might actually be able to get computers that were super intelligent. The next big breakthrough was kind of a bucket of breakthroughs, but the internet processing speeds and the huge amounts of data that as a society we collect today. Now the thinking is, if you can create the mechanisms by which a computer can learn and think like a human, then you just plug it into the internet and superintelligence arises. It's a little bit like, and then draw the rest of the owl, but that's the path to where we're going. So deep learning, another common concept that's being raised a lot today in AI. You might hear it in a lot of different fields. You probably have heard of things like convolutional neural networks and evolutionary neural networks and all of these fancy terms. But essentially, this is yet another subfield, a subfield specifically of machine learning, that is inspired by the structure and function of the brain. So the general space is artificial neural networks, where we try to create distributed ways of representing information, not too unlike how the brain does things. So with deep learning, we feed a lot of information into this neural network structure. And then basically, through a series, loosely speaking, through a series of like true and false questions, you can extract classifications of data. So that's a way oversimplification. But you send data in, there's this giant distributed network with a whole bunch of decision points, and out the other side, some lights come on. And if you ask a question here, those lights represent the answer. So we can do that now with a huge degree of complexity, and we can inject huge amounts of information. So these systems are more effective than they ever have been before. So while neural networks are not new, they've been around for many decades, deep learning is that ability to inject the huge amount of information and efficiently process it so that we can use it to make informed decisions. So this is being used in things like with Google, voice and image recognition algorithms, Netflix and Amazon recommender systems, and then we've got extensions of that, like with convolutional neural networks, which have unlocked a lot of capabilities in image processing and some of the things that I had referenced earlier. So let's look briefly at the state of the world. So Google DeepMind is one of the organizations or companies that is talked about the most these days. They've created one of these neural networks that has learned how to play video games in a similar fashion to that of humans, which was a really big breakthrough because there's a lot of decisions and a lot of complexity that goes into playing video games. It's essentially they've also worked on a neural Turing machine too. So to reference back to Alan Turing, he had a particular model of computation that up until now forced a particular way of organizing data. And today that's shifting through Google DeepMind and related companies. But overall, Amazon, Google, Microsoft, those are the companies that are dominating enterprise AI. AI for whatever is everywhere at the moment. So we've got chatbots, we've got machine learning, all sorts of supporting technologies that are appearing across all aspects of society. We've basically got an ongoing commoditization of AI creation, and a lot of snake oil slipped in there as well, too. Even game engines now, like Unity has just released their machine learning agents SDK, which is now in beta testing. This increasing injection of AI into everything is creating a trend toward things like home assistants and other services. And so we're seeing now a shift to a world where previously, for the last decade or so of the internet, we've just been shoving things in data collection, in databases everywhere. Now we're actually seeing that getting pulled back out and being used for a bunch of different services. And so we've got this passive persistent data collection and all of these tools now that are starting to surround us that are always listening, and we're combining that with AI to be able to generate both assistance for us personally, but also generating a number of questions. But what is the real state of the world today? If we were to look at the best intelligences out there, the cutting edge, we're looking at about the intelligence of a 6-year-old. And that's being fairly forgiving because, as I say, we don't really have general AI in the sense that we talk about. So even though there's a lot of hype and there's a lot of energy and excitement about where we're going, we may not be as good as we think we are. We're not very good at tracking our failures. We're very good at tracking our successes. And that means we have a very limited lens about the success that we're seeing today. So there are a proliferation of startups, of funding, of grad programs, et cetera. But we have this skewed view, I think, of AI being a more mature field than it is. So we're really still in our relative infancy. Don't worry too much about all the details on here, and I'm happy to share my slides afterward, but this is kind of a picture of how you might set your expectations for what's coming down the pipeline. At the bottom there, it's actually broken into innovation triggers, so the thing that get us focused in a particular area and drives a lot of attention and research, to the peak of inflated expectations, the trough of disillusionment, the slope of enlightenment when we start to realize what's actually key about these areas and how to be effective in these areas, and then the plateau of productivity where we pull these things into our into consumerism and all of those other areas. And so just to call out a couple of those things, so some of the things that are sitting in the innovation trigger right now, artificial general intelligence, so I mentioned that earlier. So this is starting to be a spot where people are really focusing on it. 20 years ago, people would laugh at you if you referenced this. Today, people are like, that's actually, we should dig into this, and there's tons of companies that are springing up to research into this, and many, many millions, probably billions of dollars are being thrown into this. Natural language generation, those sorts of things are starting to rise up to the peak of inflated expectations, and at the top, you see deep learning, machine learning. So those are the things that I said are being tossed around so readily right now. So these technologies are kind of peaking. We're trying to push them as far as we can. In fact, we're pushing them way beyond what they actually can do today because people see those terms and they think, oh, great, this means it's better technology. And we need to kind of get over that hump and start to understand. We need to fall back down and realize what the limits are before we can really start to practically apply these in our day-to-day lives. Autonomous vehicles are just starting to crest that area as well. We're learning a lot more about the limits of that technology, and we're starting to drop. And you see how quick that drop is. Down there, we've got augmented reality, and climbing back up out of there, virtual reality. So these are starting to get to the last couple years with all of the attention on virtual reality. We saw that drop happen in about the last 8 months. And then speech recognition is probably the most mature along this, where we're seeing what we really can do with it. It's at actually a pretty healthy and effective spot in technology, in technology today. And then just, because we talk a lot about AI stealing our jobs and whatnot, this one is a little bit hard to read the text, but just look at the big gap in the middle. On the left-hand side is low probability that we could computerize those roles today. So that's things like management, computer engineering, education, healthcare, things where you're used to having humans there, and you might get a squiggly feeling in your tummy if you think about not having humans there. And then on the far right are high probability of computerization. So things like sales, for example, service aspects, office administrative work, those kinds of things where today are already highly automated. But what's happening is as the technology grows, everything on the left is sort of shifting and swaying over to the right. So this is going to change, and it's going to change quickly. So we can't look at the left and go, okay, we'll always have those jobs. We need to actually look forward and assume those are going to be automated and start to think about what those implications are for society. Now, that was a blurring introduction. There's a ton here. One place that you can go to read more about this is the Artificial Intelligence Index, which is a new annual report that's being generated. I really like it. It's got a steering committee from Stanford, SRI, MIT, and OpenAI, so a lot of really big minds in there. And they're also very keen at having critical voices in there, so the latter part of the report includes all of the criticisms of the report as well from a selection of folks throughout the AI world. Okay, so let's really quickly talk a little bit about some of these challenges. I said I wanted to leave you with some thoughts about the state of the world and where we're going and where I think the actual relevant questions are. So we've got a lot of different, very outspoken folks chatting about AI today. Folks like Elon Musk fear the worst, kind of have a bit of a doomsday scenario that they're at least cautioning us to consider deeply. Others like Kurzweil are a little bit more upbeat about the future. The reality is we don't really know, but I think there's some very key problems that we want to be thinking about and talking about today. So one of them is just this notion of human complacency. In the transition to a more AI-governed world, we're going to lose our ability to quickly intervene. We're already seeing that with self-driving cars. There are tales of folks who have the ability to take over should the AI screw up, who sit back and passively let something unfold, even though they can see that something's going to go wrong. That's in all of us. That's just a natural human tendency. We're also going to lose aspects of society that have governed and bound us for hundreds of years and have allowed us to scale well beyond what we were able to accomplish before capitalized society. That's not saying that that's good or bad. It's not meant to be judgmental in any fashion. Just to call out that the change in these rules means that a lot of the assumptions we have today that we probably take for granted and never consciously reflect upon are going to change, and we're going to need to factor that in. Turns out, too, that as humans, we have a lot of really bad habits, and the data that we produce reflects those habits at scale, and sometimes surprising to us as well. So we are in a world where we are operationalizing bias, and we're not actually doing a very good job of algorithmic diversity. We are the architects of these algorithms, which means they bring with us our own biases. Even at Riot, where I work today, we deal with this on a regular basis. Just before I left, we realized that some of the algorithms that we were running in other countries were actually biasing against the presence of language, the presence of the English language when they were a non-English speaking country. People would see people speaking English, they would report that, which would then trigger our system to take a look at it, and so it was learning that speaking English was a bad thing. And so we had to jump in and intervene. So it's very easy, even when you're vigilant in this space, to lose, pardon me, algorithmic diversity. So because innovation will increasingly be defined by the worldviews of a single or fewer people, rather than the thinking power of many, we need to be very careful. You can imagine Elon Musk saying, I don't know, no white people on Mars. I'm not saying he's going to say that, but those are the things that these singular individual minds would be able to do if we're not reflective in this. I like this quote from Christopher Hitchens. The essence of the independent mind lies not in what it thinks, but how it thinks. We're making autonomous agents, and as humans, we don't always know what's best for us. So AI may end up in a state where it's more humane, or it may just be a vehicle for its creators' views, tacit or otherwise. We need to be asking questions about the implication of this autonomy. We should be asking questions about the responsibility for actions. As the space between the creator and the intelligence grows, this is going to get harder and harder. We should be asking questions about introducing AI audit trails and some of those harder to parse situations where when that gap gets big enough and something goes wrong, who do we blame? How do we get justice in that world? What does justice mean in that world? And as we journey through that transition from no AI to full AI, so think about a few autonomous cars today, that's the world that we live in, to all autonomous cars in the future. Everything in between is scary. There's implications for us not using self-driving cars, especially as we tip toward them being the majority. Asking questions like, well, if you're the doctor that doesn't use AI, or the lawyer that doesn't use AI, is that now ethical? At what point do we actually shift that to being a requirement? And so we're getting this generation of thinkers that are kind of a neo-Luddite of sorts. To resist technology today is a matter, essentially means that we're resisting society in a sense. That's not a productive way forward. So how do we find this balance that's going to allow us to transition gracefully into this new world, or to pump the brakes at certain key points? From another perspective entirely, as these entities gain in intelligence, where do things like AI rights start? As humans, we can't even decide when a human becomes a human. How are we going to decide that on the part of AI agents? We have ahead of us a sort of emancipation approaching us, right? A liberation from our current legal, social, or political restrictions. And this, in turn, is going to undermine our current way of living. Today, in a capitalist society, you spend your life largely doing something for somebody else, for the average person. And AI is changing that, right? Capitalism's greatest threat is its own progress that it supports. It's not necessarily bad, it just raises the question, what are we going to do? What sort of revolution is coming? We're getting a chance to ask the question, what kind of society do we want to have? But AI is not evenly distributed. It's in the hands of the wealthy or soon to be. And here's the really scary piece. In a sense, AI is actually the last commodity. It's likely to end up in only a few hands. AI isn't just a static piece of IP. It's capable of building new monopolies, businesses, and things all by itself. When you own the product that creates the monopolies, that's a fundamentally different model. Human thinking is going to end up in only a few hands. Lastly, thinking about moral agents and this idea of being able to question the maker. People talk about friendly AI. This is the counter to the robot apocalypse view. And some people believe we can't actually create friendly AI, given our current technology, suggesting that we actually need to create seed AIs and seed those AIs to go learn about humans, figure out what's best for us, and then devise what we'd actually want. Alternatively, we build a scaffolding model, in which we build a provably safe AI and then build the next generation from that. There's also folks like Lewandowski, who's purporting to create a church of AI, basically just realize that there's going to be this godhead based on artificial intelligence and lean in, accept it. Don't let it become restricted in the form of capitalist thinking, but build a church around it and do a more worship-like model. So some very extreme thoughts. But we're actually moving towards a divergence point. The reality is that some point in the future, we are going to have technology that no human will necessarily understand. It's going to be self-sufficient. That's kind of the goal. So what happens when, I don't know, the stock market breaks, a hospital goes down? Who fixes it? At this point in time, we will actually have no recourse. So it's not the robot apocalypse that we actually should be the most afraid of. It's actually when we no longer can fix our own technology, and we are now completely at the mercy of the technology we have created. This is where we need to be thinking today and challenging assumptions. Facebook, for example, is actually kind of like that already. Informed consent is not really a thing because most people don't understand these systems or how that information is being used. So even though you're asking, the average person isn't necessarily understanding the question. So they might be okay with something, but don't really realize the implications. We're facing small behaviors in society, small behavior changes, in society over time. And if we wait to see the big overt swings, then we're going to miss key opportunities to actually take and shape our future in a healthier way. We need today to better understand the slow and insidious changes and then calibrate to be more responsive going into this future. So we are facing a deeply transformative time. We are going online. We are connecting in ways that we have not evolved to handle. We've got a lot of catching up to do. And we're moving really fast. We're probably 5 years out from quantum computers, which are going to change and break absolutely everything, and potentially might be the accelerant that's going to drive AI toward general intelligence. We have countries like China in particular, that is dumping many, many millions of dollars into AI technology. They have a state council plan to be the AI innovation hub by 2030. AI is an opportunity to understand ourselves better. It provides a lens through which we can better understand humanity. It provides an opportunity to challenge ourselves to reach new levels never before dreamed by previous humans. And it's also an opportunity to free society to explore new models and to improve upon globalization. But we are at a key period today that even though we're in our relative infancy in AI, we are at the point of potentially becoming too late if we are not starting to ask some of these questions about the nature of the society that we want to have and how we can continue to be the architects of that future. So the question is, will AI be the last human invention? Will we be evil by accident? The truth is we have no idea. The greatest danger is that we're not asking the right questions soon enough. A cultural revolution is upon us, and it's up to us to decide whether or not it will be a renaissance or a coup. Thank you.
Kim, Kim, thank you very much. That was a fantastic introduction. Before you leave the podium, and it's a fantastic way of going into our next speaker as well, who's going to be talking more about the ethics of AI and so on. But before you go, let me ask you a question. I mean, how much time have we got, do you think, before superintelligence, especially in the light of your point about no one will understand the tech, how long have we got, do you think, before we have superintelligence? And is the route to that, do you think, machine learning, neural networks, or do you think some other form of AI will actually lead us towards that?
Yeah, you know, depending upon how you look at it, we could be as little as 5 to 10 years out, or we could be, at least, I think within 5 to 10 years, we will either be on the verge of achieving it, potentially achieving it with what quantum computers will unlock, or I think we will understand more of the theoretical limits of what we're going to be capable of doing. And so 10 years from now, I think we'll be able to say, if we're not there yet, no, we can't get there, or yes, we can get there. So I think that's actually a pretty significant turning point for us, because at this point, we actually don't know what those limits are, and there's a bunch of different theories. And all of these technologies, you know, all of the various machine learning algorithms and whatnot, there's a lot being dumped into those right now. We haven't actually had any major breakthroughs beyond our ability to process very efficiently. And so I think we're still kind of feeling out what the ceiling is in that space. But there's plenty of room for new algorithms to come in and surprise us, or new ways to connect things, or you know, the orders of magnitude gains that we will get from quantum computing.
Well, I certainly hope you'll come back and tell us as soon as you know the answer to any of those questions. Thank you very much, Kim.
Thank you.
And now I'm going to go on to Michael Phillips, who's the Associate General Counsel of Microsoft, and he's going to speak about principles, policies, and laws for responsible AI.
Yeah, you bet. All right, we're live. Fantastic. So thank you very much. It's a pleasure to be here with you all this morning. And just to give you a quick sense of what I do at Microsoft. Oh, fantastic. Thank you. I am responsible for a couple of different things. And for quite some time, have supported different aspects of Microsoft's product development. For the last 4 years, that means I've been our Bing business, search. And a lot of our search clients will tell us, hey, look, internet search is one of the first great examples of AI at scale, the ability to take the internet, the content of the internet, and make it searchable, and make it searchable in an intelligent way is a great indication of what AI is capable of doing. And I've supported that organization now, again, for 4 years and dealt with some of the issues that they've come across. I've actually been at Microsoft for about 19 years now and have been in a number of different product-facing roles. The last probably year of my time at Microsoft, I've branched out a bit to cover more of our policy work, specifically our policy work around AI. And that's really been an opportunity now to get into these fascinating questions that Dr. Voll was just referring to, sort of the ethical implications of this technology and these technology breakthroughs. What do they mean for us? So I spend a decent amount of my time now working primarily with our Microsoft Research organization, the folks who are on the cutting edge of Microsoft's efforts to implement and deploy AI technology, in thinking through precisely what it means for society to do these things, and how should we think about doing these things responsibly. And as part of that, of course, as a lawyer, how do we think about the regulatory and policy environments? What aspects of AI should be regulated and how? What's the right way to go about deploying and building responsible AI? With that, I'll kind of dig in. This is a slide I actually used just a week ago in an internal conference that I spoke at Microsoft called TechFest. And the session that I was at that day had to do with explanation of AI, or transparency of AI. How does one explain what's going on? And it's a little bit of a segment of some of the policy and ethical issues that folks are thinking about today. What does it mean when AI goes and makes these sorts of decisions, and what do we do about them? But the point of this slide was really to just draw from today's headlines. I think, as Dr. Voll described, there's sort of a sense of society being at this existential inflection point, that AI has the potential to dramatically change human life. And as a result, I think there's a tremendous amount of anxiety and concern, not just among the average consumer or citizen, but certainly among policymakers and regulators, those who build AI, those who think about what the future of the technology should encompass. There is just, suffice to say, incredible anxiety, I think, about where things are going. And so this was just a random sample. I think on a daily basis, one could look at any number of publications and see all manners of op-ed pieces or articles that talk about specific issues and the potential problems and opportunities that AI pose. In fact, one little piece of show and tell, I love reading The Economist for a lot of reasons, but really on a weekly basis, they'll have something in there that describes what's going on with AI. And this week's edition, the cover is all about AI Spy. There's a special report on the use of AI in the workplace and what that means. And I think, again, it's just another great example of how live and rich these issues are. Having said that, I think it's worth taking a little bit of a look back in history. This is a cover from Newsweek in July of 1970. And the point of this article at the time was to basically raise a red flag about the degree of data collection, that the data trail, so to speak, that human beings were leaving behind them were suddenly becoming much, much greater than anyone had the ability to think about previously. And a lot of that was as a result of the emergence of computers and the ability to store data at that time on magnetic tapes. And this article worried that this was going to limit humans' ability to kind of control where technology was taking us. That the notion of being anonymous, the notion of having real privacy in one's daily life was out the window because each of us would be leaving a data trail that could later be explored and analyzed for years and years and years. And at the time, in 1970, in the US at least, this article went into some depth about the challenges to trying to address credit issues, so that if you were applying for credit, you were building a credit history. With the fact that these technologies were making your data so much easier to retrieve, it was becoming extremely difficult to correct errors if you thought errors had occurred. And this was, of course, before legislation that gave consumers additional rights in the US, for example, through the Equal Opportunity Credit Act in 1974, which would give you some ability to wonder and question why credit decisions were being made the way they were. And in part, those were intended to address discrimination and bias in credit decisions as well. But again, at the time, this article worried, is this technology really, frankly, going to change humanity in a way that makes it impossible for us to recover? So the point of this is to say, this notion of technology getting out ahead of humanity and people being worried, having a lot of anxiety about the future is not new. And I think it's worth keeping in mind how that's worked in the past and what that's meant. But I don't think that there's any question that we're today at the cusp of, again, what is a very, very significant inflection point. And I think, as Dr. Vold described, lots and lots of advancements now in AI, which itself is not a new phenomenon. Again, you're talking 50 or 60 years in this space, dating back to Dr. Turing's work in the late 1940s, early 1950s, the conference at Dartmouth in 1956, where the term AI was coined. You've now had decades of work in this space. What's really kind of gotten interesting now in the last probably 5 to 10 years, and the reason why this is so real for us, there are a number of factors that have influenced this explosion. And I think first and foremost, it is, again, this question of data, the explosion, frankly, in the amount of data that is available to society. There are some just mind-blowing facts and figures. I think there was an IBM paper a year or two ago that said oops, I think I lost. We're good. The amount of data collected from humankind within the last 2 or 3 years by far outpaced all data collected from the earliest stone tablets until now. And so, on a yearly basis now, the exponential increase in the amount of data left behind by humanity is beyond anything that we've had the ability to comprehend. And again, it's that availability of data now that makes AI really so interesting and capable. It really has made it a question of scale. So now these technologies that showed great promise, that have enabled us to defeat the chess masters, that have enabled us to defeat those who are the champions of Go, for example, this is made all that much more real by the fact that there is so much data available, and data is so much easier and less expensive to store and gather. In addition, you now have computing power that, again, is exponential compared to what was there. And again, as Dr. Vold described, I think we're maybe having some technical issues. This could go to yet another extreme level. So today, computing power that's available to really any developer through the cloud is beyond anything I think that folks had the opportunity to use in the last 5 to 10 years. And that's only going to increase. If quantum computing really does factor out and arrive in a manner that those who are working on it expect, within 5 to 10 years, the computing power that will be available will make what's available today pale in comparison. And so again, some very, very interesting questions about what all that means. And then lastly, I think you've had some real advances now in some of the AI techniques that are available. Algorithmic development that helps these systems reason and work in uncertainty. There have been great advancements in that in the last 5 to 10 years, I think. So this confluence of factors have taken us to this point where the people are excited and anxious about it because the scale of the technology and the availability of the technology across the board is so much more significant than it ever was before. We've been thinking in the policy context about, okay, so what does this mean for the average person? And I think this notion that now, through this technology, machines are going to be capable of really perceiving the world around them through image recognition, through vision, and through speech recognition makes this now a situation where a first step perhaps towards a general intelligence, but certainly this specific perceive the world around it and act upon the world around it, that's a real thing now for AI technologies. And then the ability to comprehend the world. So not just to hear and see what's going on around it, but for a machine to actually be able to comprehend the meaning of spoken words. And to be able to reason over the world's knowledge through indexing, to be able to correlate and relate different pieces of data to other pieces of data, begins to give machines that ability to not just sort of do very specific and carefully programmed tasks, but then to be able to think in a way that a human might to reason over a situation under uncertainty and do something with that. That's, I think, the point that we're at now. Certainly from a policy perspective, that leads us to think about these issues in a whole new way. And of course, as we think about what AI is capable of, I think we're all tremendously excited. This is sort of the positive side of this phenomenon. There is just such tremendous potential for AI to drive huge change within society and improve the lives of really every human citizen in any number of ways. I mean, this slide is really just scratching the surface, but there have been quite a bit of discussions around the improvements in education that are capable or possible through AI. Definitely the improvements in healthcare. Dr. Vold referenced the ability of AI now to spot and detect skin cancer in a way that can meet or even exceed the abilities of dermatologists. Certainly, one has heard of examples of AI systems crunching millions and millions of images to detect cancer indications that really the best radiologists previously were unable to do because of the scale of the technology and its ability to crunch data. Agriculture, another place where I think there's tremendous excitement about the ability to use sensors to determine environmental conditions and do a much more effective job of planning crop rotations and the like, and therefore, leading to developments that will increase food productivity in a rapidly growing population. And then lastly, this notion of transportation, which I think is one of the best places to kind of explore the pros and cons of the technology and the challenges for policymakers. I'm sure most folks in the room heard about the incident a couple of weeks ago involving Uber in Arizona, the first death involving an accident where an autonomous vehicle was under its own control, albeit with a human overseer who was apparently not able or aware of the situation and able to correct it. But it brings up, again, a very deep and rich conversation about whether or not this technology is a good thing. In the U.S. alone, I think at this point, the annual death rate on the U.S. highways is something like 40,000 a year, and then another million or so people seriously injured in automobile accidents. And I think it is not hyperbole to say if autonomous vehicles really do take off, you could see those rates of death and injury declining dramatically. But how do you get there in a way that people feel comfortable with? The first instance, which we've now had of an individual being killed by a machine, makes people wonder whether or not the technology can be trusted. Of course, if the reaction to that sort of an incident was, okay, we cannot trust these machines, let's shut this down, you could argue there are potentially thousands and thousands of lives that will be lost because we can't get to that point where autonomous vehicles are actually able to drive much more safely than humans can. So again, a place where plenty of rich conversation about what to do about it. As we've thought about the policy environment and how to think about working with regulators and policymakers to drive towards an environment where AI can be best supported, where the innovation and the potential of AI can be realized, but done so in a safe manner, I think we've realized that this really has to be done through industry in the first instance, being very careful and thoughtful about the way it builds and deploys AI systems. And so at Microsoft, we've been thinking about AI in the components and the pillars of responsible AI in this fashion. This really isn't novel. I think if you look at what almost any big companies, certainly, and I think small companies as well, that are in this space as they think about what it means to do AI responsibly, the same themes come back, which I think is a very good thing. I think you see within the industry this trend towards recognizing a tremendous responsibility and needing to think through and arrive at these technological breakthroughs in a successful way. So what I want to do with these few more minutes that I have is kind of walk you through the way we're thinking about these different pillars. Across the top, we've got these notions of fairness, which will certainly touch on questions of bias and in data and algorithm development, as Dr. Wool suggested. We have big questions about reliability and safety, again, autonomous vehicles and beyond, questions of privacy and security, what's happening with our data, and then this notion of inclusiveness. How can this technology be built in a way that really augments humanity and ensures that all human beings have the ability and the opportunity to benefit from it? And then underlying all of this, again, these couple of notions of transparency. Really, frankly, how do we understand what's happening within these systems? And then finally ensuring that humans remain accountable for what systems do. So I'll dig into this a little bit and start with this question of fairness. Folks may have seen the recent press on this issue too. There was a paper that was done just over the last couple of months that talked about facial recognition systems from Microsoft, IBM, and one other provider that I can't recall at the moment. And the question or the issue here that they spotted was that these facial recognition technologies, which were really doing some amazing things, tended to work much, much better if the subject was a white male. So white male, the ability to recognize a white male in an image was something around 98, 99%. Darker skinned females, the success results or the efficacy of the systems were much, much, much worse. And of course, the obvious question is, why the difference? And as they dug into this a little bit, they realized this was really a question of the original data. The data that was used to build and test these systems was primarily databases, pictures of white males. And so I think it's a fantastic example. It's a relatively easy one to digest and understand, but it highlights the importance of being very, very careful and very aware of the data that one uses to build AI systems. And in many ways, while it's easier to sort of see this once you realize what the problems are, more opaque forms of data make it even more difficult to know what you don't know. So where you're building a system and you're using data to do it, we believe there's a lot of work that needs to be done to really analyze that data very carefully to determine whether or not human biases are making their way in. Quite a bit of press over the last year or two about use of AI systems in criminal sentencing and the risks of taking data from one location or from one neighborhood and applying it in other places, the risks of not analyzing the data carefully for what may have been biased policing results, for example, over time. When these biases are built into systems through the data that's collected and used, the risk becomes that you're either exacerbating the problem or you're encoding it in a way that makes it that much more difficult to detect. So the point of this is to say, to be responsible, it really is going to require that we're very careful and very thoughtful about ensuring that systems that we build are fair and diverse. And that in part leads to this point about needing to ensure that those who are working on the systems are also diverse, that we ought to be attracting talent from across racial and gender and other spectrums so that what's being built represents society as a whole. Talk just a little bit about reliability and safety. Again, the Uber accident is a great segue into this, just thinking about the extent to which systems are deployed. And again, this is an area where I think there is quite a bit of anxiety. It's worth taking a step back, though, and realizing that we've been living with automated systems for some time. I think any of us, very few of us, probably get out of an airplane anymore and worry too much about autopilot. And yet the autopilot systems in an airplane do 90-some% of the flying. And I think we've gotten to a point where we recognize and understand the technology. We feel like it's adequately regulated for the most part, that there's enough understanding that we can trust it. And so I think it's important to recognize that we've been able to get to that place with certain technologies over time. Today, as automation is making its way into more and more systems, and it's becoming more prevalent, and certainly automobiles may be the single best example because of, again, the scale of these systems. It makes one think about, all right, what's going to need to be done? How do we bring that same rigor and sense of trust and control that we've established in places like aircraft into these broader use environments? So again, really figuring out how to test these systems extensively, how to monitor them and ensure that they continue to work as intended. And again, you see this recurring notion of ensuring that humans stay in the loop. And this is going to be an interesting topic, again, coming out of this Uber incident. Was the driver who was in the car paying attention? Was he able to correct the system if he'd been doing what he was supposed to be doing? Will there be opportunities in similar cases for humans to become involved? And of course, this is a tricky question as AI systems become more prevalent and faster and more useful across a variety of environments. Is there really going to be time for a human to intervene? No place I think is this more of an interesting question than in military application. To the extent AI is deployed in drones and other places, will humans really have a meaningful opportunity to intervene if the system starts going off in a direction that's not intended? And if the answer to that is no, just practically it would not be possible for that to happen, then certainly in the development and deployment there will be other interesting questions to ask about when a human should actually rely on this sort of technology. The military talks about maintaining human in the loop, or at least human on the loop, with the ability to correct. And as this technology is deployed, one would hope in a responsible fashion, that'll be probably the single most fundamental design principle that would have to be maintained. Privacy and security, again, a big area of concern, certainly with the General Data Protection Regulation now about to go live here next month. I think most companies have been spending a tremendous amount of time ensuring that they can comply just with respect to their normal data collection practices. The data subject rights that give individuals the ability to see what data is collected about them, to delete data as needed, to require companies to do other things or not do certain things with data, all are now very real, and hopefully most will be able to do that correctly now out of the gate here starting in May. But for AI, I think it raises these questions and challenges to a whole new level. How do you ensure that individuals whose data is collected and used by these systems really do have the opportunity to understand what's being done and to exercise their choice? That's not an easy thing the more automated these systems become. And then, of course, there are the questions of how do you secure data in a way that prevents AI systems from being hacked. And data manipulation, I think, is one of the areas that folks worry about considerably in this space. To the degree one is able to influence data and propagate systems with data intended to reach adverse outcomes, is that something that we can even spot and track? So I think a lot of work going in right now to figuring out how to do that in an effective way. And then this notion, again, of inclusiveness. I think a lot of folks are very optimistic about the ability of AI to help those with disabilities do more. And I think there'll be some demos later in one of the later sessions about Seeing AI, which is a Microsoft app which enables the blind to experience the environment around them. And I think that just scratches the surface. So AI could do tremendous good here. But even beyond sort of the obvious uses, the point here is to make sure that AI really is designed and deployed in a way that augments human beings and doesn't replace human beings. So how do we design this technology in a way that is human-centric and addresses some of the concerns that Dr. Vold described? And then lastly, I'll just touch again on this notion of transparency, the importance of making sure we understand how decisions are made. I think early on there has been some call among policymakers to make sure that they could review algorithms, possibly look at source code, and I think most are coming around to the point where they're realizing that's probably not that helpful. And I think most data scientists will tell you as deep neural nets operate, even they can't tell you what's going on. And so to look at the code or to try to parse the algorithms is going to do nothing but confuse the matter. So how do we build systems that can explain what they're up to? And I think this is an area of really promising research where there is AI being used to explain AI. So we're building systems that would work through the way and the progression of inputs to outputs and find a manner in which that could be essentially translated for human understanding. A lot of work's going on here, and I think this may be the single most important thing for industry to do now effectively over the next couple of years to ensure we have trust in AI, and that is to make sure that this stuff can be explained at a human level. And then lastly, again, the notion of accountability. So humans are ultimately responsible for what gets built. There are a few folks that I've spoken with who really don't like the term artificial intelligence because it has this sort of negative stereotype that what we're really talking about is computational intelligence. You're taking the ability of computers to crunch data and do things, but ultimately computers are still programmed by humans. And yes, deep neural nets and unsupervised learning systems come to their own conclusions based on the data, but ultimately there's still a human there in that loop. And so thinking about how to make sure humans stay there and aware of what's going on is going to be really important. There was a really interesting quote I read recently that talks about, again, sort of narrow AI, as Dr. Voll explained it. Today, you almost could liken what these systems are doing to taking a room full of statisticians, giving them unlimited resources and unlimited time, and they will create models and crunch data. That's essentially what AI is doing now. It's just able to do it much, much faster and with much more data. And so if we kind of come at it from that angle, I think you again can understand how humans should interject and make sure that they're responsible for what's going on with the systems at the end of the day. So I'll just close on thinking about, all right, so what does this mean from a policy perspective, and how do we talk to regulators about how they should be thinking about the technology? I think we certainly believe, first and foremost, it's going to be incredibly important for the future of the technology to take a very careful approach to regulation. There will undoubtedly be situations where politically it may be feel beneficial to get out and regulate it. And again, I think this Uber situation is going to be fascinating to watch. You've already seen in the state of Arizona, which had distinguished itself from California and a couple of other states by making it much, much easier and less regulated for these automated system designers to deploy their systems. They've already changed their tune, so then now they're starting to restrict what parties can do. And absolutely understandable. What we don't want to see happen is, as these sorts of incidents come about, that there's this knee-jerk reaction to go and restrict the technology. I think it has to be done very carefully. But to do that, it's going to be incumbent upon industry and civil society to work together to figure out, okay, how do we really do the things that we just talked about? It's fine to publish principles for responsible AI, but you really need to go out and build it and show it. And so we think that starts with multi-stakeholder dialogues. There's an organization, numbers of organizations that are working on these sorts of issues. One that Microsoft is involved in is called the Partnership on AI. It includes IBM, Google DeepMind, Amazon, and some others as founding partners, and has grown to 50 or 60 members. And the entire idea really is to take these sorts of issues, talk them through, and share best practices. So for example, to the extent a company feels like it's making breakthroughs in transparency or in detecting bias in data, we want those really to be out there and be shared and be leveraged across the industry. We think that's going to be really, really, really important. Again, we're developing and advancing these principles and trying to do so as quickly as we can. We think government can really support the innovation as well by helping to fund some of this work, by helping to fund research and development, thinking through data. Again, I pointed out data is going to be extremely important, and notwithstanding that there's so much out there, the truth remains that to get valuable data for AI still requires a lot of work. Data often needs to be labeled. So the more we can do to expand the available data sets, and I think governments sitting on tremendous amounts of data can partner and do that in a way that is more effective. And as I noted with the example, maybe you have a system where you've got data sets in facial recognition, for example, that are much more representative because we've been able to bring more data to the table. I think governments will be super important there. And then lastly, we didn't talk much about this. I know Dr. Voll referred to the impact of AI on the workforce. I think that slide was fascinating to kind of show where we're perceiving implications for different types of jobs. There's no question AI is going to displace workers. But we believe that will happen in a way that's very similar to other technological breakthroughs over time. If you look at the early 1900s as society was transitioning from horse-drawn carriages to automobiles. Anyone who was involved in farming and the like that was centered on horse-drawn vehicles were put out of work. And yet, over time, I think more jobs were produced. Certainly, I think that's going to be the reality here as well. But it's going to be incumbent upon industry and government to help get the workforce through those challenges. That'll be a big part of ensuring that AI lands successfully and in a responsible way. And that's all.
Mike, thank you very much indeed, and you've taken us into that whole area of ethics and regulation and, as you say, the design to earn trust. But aren't you isn't there a quandary here? Because you speak from the perspective of, if you like, a leader in this conversation, this whole issue of trying to adopt a voluntary code of ethics and so on, and isn't that only really applicable to the best companies? What about the bad actors? What about trying to get, if you like, agreement internationally? Doesn't that inevitably mean some kind of regulation?
Yeah, it's a great question, and you're so right. I mean, it's, you know, the Google, DeepMind, IBM, Amazon, Microsoft. We're in this space, and we're able to get out ahead and espouse these sorts of principles. Is it really realistic for every developer who wants to be in this space to do these same things? Some of the things we talk about are not easy or inexpensive. Developing systems that are transparent, for example, there is a real cost to explanation, and is that possible? And then certainly you're going to have, I don't know, maybe on the extreme end you'd have true bad actors, but you will have others who may be willing to take ethical positions that others may feel are not warranted. And I think in the space of law enforcement or military applications, there may be some who are willing to do things with the technology that others may not be careful with. And so I think you're right. I think at some level it's going to necessitate that there's comprehensive regulation that can look across that and assume the potential for bad actors or questionable actors. I think for now, where we'd encourage the space to go and for policymakers is to be very cognizant of that and to invite comment. I think one of the reasons why an organization like the Partnership on AI is so valuable is because it's bringing in civil society. The American Civil Liberties Union, for example, is heavily involved there to make sure that those sorts of concerns are voiced and very, very, very apparent. But certainly then I think that gets you to a point where you're going to know there may be certain situations where regulators will have to get involved earlier. I think, again, on the military side, I would not be at all surprised to see efforts to try and reach international treaties that would say, look, either AI shouldn't be deployed in military contexts, or if it is, there are understandings and agreements as to where humans would have to be in that loop. And then, of course, the question will become, you know, can you get to a state where you can trust all the actors in achieving those aims or not? And from there, you know, regulation will have to respond.
Thank you very much indeed.
Of course.
Which leads us very neatly on to Professor Chris Reed, who's the Chair of Electronic Commerce Law at the CCLS, and he's going to talk about AI in gaming. Should we require transparency to achieve safety? So we're into the real legal area.
Well, thank you, Tim. And yes, I guess it's the job of lawyers to puncture people's dreams. Right? That's, yeah, so the title of this is Dreams. But we say, look, let's bring it down. Let's do something boring and staid and safe, and let's deal with risks. And that's what the regulation question is all about. Yeah, what should we actually be doing? And so I've been doing some work on artificial intelligence and liability and risk and regulation over the last couple of years. And Tim has suffered having to listen to me when taking evidence for his committee. Some people here have heard me talk about some aspects of this topic. I've not looked at it in relation to interactive entertainment because I have absolutely no pedigree in interactive entertainment. No, seriously, I played the original Space Invader machines back in the 1970s, and that was really my last serious brush with interactive entertainment. So I had to do some serious research for this, and I spent an hour on a search engine. We have to be very careful with Michael in the room. I used a search engine, and I spent about a whole hour, maybe a bit less, and I discovered, okay, what's happening in interactive entertainment and virtual reality and stuff like that, where AI is likely to be used. What's actually going on? And I came across a number of interesting things, which I think may help us to understand the worries, the regulatory worries, and what we can do about them. So number one was, okay, we're going to have actually autonomous agents happening in games. They're going to be quite realistic. They're not just going to be some kind of slab creature that looks up and speaks a script at you, but they're going to interact with you according to what the context and what you're doing and what other people are doing. And they'll have accurate emotional reactions. That's interesting, because the more like reality the environment is, the more you behave in the way you would behave in a real environment. It changes your behavior. Right. Making virtual reality more real. Right. So things like, at the moment, if you have an animated character that's doing a kind of pre-programmed sequence, it looks pretty cool. And then there comes the point when they're reacting to other things and their movement gets a bit clunky and it's not so exciting. And artificial intelligence is being used to actually allow the character to understand how they move themselves, rather than have that imposed on them by programmers. So they can react to unexpected, unprogrammed things in a realistic way. You can put knowledge into objects. So if you're going to blow up a tree with a single shot, then it will know how to blow up. And it won't blow up the same way every time as a tree will currently do. So that's interesting stuff, like, is it going to injure somebody nearby when the splinters fly off? It depends how your projectile hits it, which depends on a whole load of other things. And there's also work going on pedagogic agents inside the game who teach you things, right? Or maybe even pure teaching tools that are entertaining but teaching at the same time. So I thought these might be interesting to think about in terms of the regulatory problem. And the regulatory problem is kind of twofold. Right? Part one is about real risks, which is what I'm going to talk about, but the other part of it is about regulatory panics. And regulatory panics are things that are hard to resist, and we're just about to begin one now as far as artificial intelligence is concerned. And regulatory panics about these things date all the way back to Mary Shelley's Frankenstein, I guess. We get really worried about things that behave a bit like humans but aren't humans. Right? And that goes all the way back to the golems and beyond. Right? We're very worried about things that we think might be acting like humans, but they're not humans, so we don't understand them. And our first reaction is we've got to do something about it. It's much better, I think, to start with the problems. And of course, to start with the problems, you have to look at the real problems, not the ones that come out of the moral panic. Because if the moral panic takes over, then interactive entertainment is first on the hit list. Because interactive entertainment gets ideas direct into the minds of children. And once you are going direct into the minds of children, then we're going to regulate the hell out of you, because that's the only safe thing to do. If we start from what's really happening, then we discover that the things that are happening are not necessarily the things that people worry about. So people worry about robots running amok and artificial intelligence making decisions that wipes humanity off the face of the earth. Right? That's not the real risk. The real risk are things like machine learning incorporating the devices of humans. Because we saw the example of face recognition. You know, if you take a picture of all the developers at a fairly standard West Coast technology company, right, they are going to be predominantly under 35 and male. That's what they're going to look like. And it's going to be really good at recognizing men under 35 and rubbish at recognizing everybody else. Right. The same thing happens with all the other problems that humans have. Right. So, for example, you have in-game learning by autonomous agents, which is great, right? But who do those autonomous agents learn from? Well, they learn from the other players. Right? What happens when you set an AI loose to learn from humans? Well, the Tay chatbot on Twitter was a pretty good example, right? Because here we are, that's what it learned, okay? That's who it was hanging with, bunch of anti-Semites. They told it, yep, okay, this is what you know. And it was very good. It picked up what they knew really well. And the problem was, as somebody once wrote, the makers of that sorely underestimated the vast potential for people to be assholes on the internet. Yeah, we're humans, right? We do that. We're not always nice people. So we have to think about, that's one of the risks, that they learn our bad side as well as their good side. And we'd rather like AIs to only be as good as we are and not to be as bad as we can be. Right. And there are other kinds of unwanted or unlawful learning. Discrimination is a particular problem, and you can see that an autonomous agent could very quickly learn to shun people of a particular skin color, which of course, in the gaming context, might not necessarily be human skin color, normal one. As Kermit, it ain't easy being green. He's not going to get to play the game because we've learned we don't like green people. Right. Is that a problem? It's not currently within anti-discrimination laws, but as these things become important, I don't know. And there are unknown limitations of teaching or training. Yeah, the use of AI to teach people things is great, but what we don't always know are the limitations of what it has learnt. And we have the example of automation in aircraft. And that's one that's quite dear to my heart because instead of playing on interactive entertainment, one of the things I do is I go and fly gliders. And so I'm quite used to doing hand flying. Yeah, the stuff where you're in the aircraft and you're making the aircraft work. Right. But if you look at modern flight training for airlines, most of that is conducted in simulators already, but with a human instructor. And the idea is the human instructor has been in real planes and knows what real planes do. But increasingly, people who learn to fly planes and become instructors are doing less and less in real planes and more in simulators. And the danger is at the boundaries. The Air France 447 crash, you may remember that from 2009, flying over the Atlantic, hit adverse weather conditions, various system malfunctions happened, and it ended up flying like this. Now, that's not good. That's pointing upwards, right? Eventually, gravity wins in that situation, and your aircraft stops flying and starts to stall, or what non-pilots call fall. Right? So at this point, it is falling out of the sky. Right? And they didn't know what to do. And the reviews of the cockpit recordings and the instrumentation are suggesting that they really had no idea what to do because they'd never been in that situation before and their training hadn't fitted them for that situation. Right? If they've flown a glider like I have, we spend a lot of time making our gliders go out of control so we can learn to put them back in. Right. And the same is true if you do training on a real aircraft. You can actually make it do things that go wrong. And there are sensations, physical sensations and feelings that need to be captured because you hear the difference and you feel the difference in the controls, and that way, that tells you what you need to do to get control back. If that isn't in the automated learning, you get a problem like that. So, and the problem is that we don't necessarily know the limits. We don't know what we don't know. That's one of the difficulties of machine learning. So let's think about possible risks that we might want to regulate then. Right. In the interactive entertainment space, one of them is emotional or psychological damage to players. Right. Because you can imagine these AIs leading human players to increased acts of violence. Right. They start off being a little bit violent and they become more and more violent until, if they're susceptible to that, they suffer psychological harm. That's one possibility we might want to guard against. We've already had the first rape in cyberspace, and that was back in a text-only Dungeons & Dragons game, Lambda Moo, back in, I don't know, 1980s, 70s even? Early 80s, I think, yeah. Julian Dibble's piece, A Rape in Cyberspace, is well worth reading. Right. But, okay, what would happen if a human character was raped by an autonomous agent, just as an example? Right. That seems pretty traumatic to me. That seems to be something that we wouldn't want to happen. Right. What about physical injury? You begin, physical injury? Well, what I discovered was that there's people who are working on a tennis game using the HTC Vive device. I didn't know anything about that, so I looked it up. And here's someone playing with the device. Right? Now, they're playing some kind of virtual game, maybe tennis, maybe not. Right? But has the AI managed to program in that table lamp and that chair and that telescope, all of which are injuries waiting to happen? Yeah. You know, so you can see the way physical injury might come into this. What if I do that? If I try and stand like that, I'm going to fall over, let alone anything else. Okay. Carelessness or even fraud from AIs who are teaching you stuff. Clearly liability for that. If some technology has taught you something you're supposed to rely on and it turns out to be untrue, there's the possibility of liability for carelessness, or even, you know, someone putting a technology out there that fraudulently teaches you things like give me all your money, or whatever it might be. You could see maybe some religions are quite keen on, no, all religions pretty much are keen on getting your money. So you could see them putting out a game that made you feel predisposed to give them money. What about teaching unlawful discrimination? Right. Yeah. Why wouldn't an AI do that? Because it's learning what to teach from us, and we're constantly discriminating all the time, often unlawfully. No frogs allowed. Okay, so regulatory responses, how do we deal with this? Well, the standard regulatory response is to say, oh my goodness, this is frightening. It's to go back to Mary Shelley's Frankenstein. This is a force we do not understand. If we let it out uncontrolled, it's far too dangerous, so we must control it. And last year's European Parliament Committee Legal Affairs report was exactly that. It was started off from robotics, which of course are much more Mary Shelley than anything else. But it incorporated artificial intelligence as well and made much the same comments. And this is what it said. It said it wanted registration of advanced autonomous robots, and including advanced autonomous AI systems as well within that, even if they had no body. So you have an autonomous AI system, right, let's register it, and in order to get registered, you have to be tested and certified, and you can't put this on the market without approval from the registration body. So this is a fairly standard regulatory response. Okay, you can only do it if we look at what you're doing first and we test it and certify it and make sure it's safe before we let it out into the world. On top of that, there should be transparency. Right, now, regulators love to talk about transparency without thinking what transparency means. And so they say it should always be possible to supply the rationale behind any decision taken with the aid of AI. Well, we've already heard it's not always possible to supply the rationale behind any decision. And sometimes we might want there to be a clear rationale that can be explained. Much of the time, we're not bothered. I'll give you some examples in a bit. Right. Would this lead to the death of innovation? Of course not, because all artificial intelligence research would move out of Europe to somewhere else, where they didn't regulate it out of existence. But if the world adopted this kind of system, you can only use an AI if you can convince a regulator that it's perfectly safe before it's let loose. Then that's pretty much going to act as a strong disincentive to doing any work at all in the field. Right. I mean, you know, even games, okay, for games you get a rating, an age rating, about who should be able to play it. But that's about all. Imagine if the game had to go in for approval by a regulator before you're allowed to release it. I don't think we'd see many games. So, what about transparency, though? Because that's mentioned there. Michael's talked about transparency. And could transparency help us? Well, it's quite helpful if you look at... Okay, let's ask what transparency is first. First thing we need to realize is that transparency isn't a simple concept. You can't just say, I want transparency, and expect people to know what you mean. Right? Because transparency depends on who you're telling things to. Right? Think about the idea of a black box. You've all heard of the concept of black box technology. We don't know how it works. It's a black box. Inside it, something magic happens, and stuff comes out the other end. So we put stuff in, stuff comes out. Inside, black box, we don't know. Okay. Now, how black is the box? Well, if you're the producer of the box, not very black, right? You know how it works. Yeah? Or you have some idea how it works. What's interesting is that if it's got AI technology in it and it's using neural networks and stuff like that, it's quite hard to find out exactly how it works, except by reverse engineering from the results to get some understanding of what's going on. But at least producers have some idea how it's working. Right? On the other hand, if you take users have no idea how it's working. Yeah. You guys drive cars, right? How many of you really know how your car works? Right. Not many, not these days. Not many. Not like me. I used to drive very old, very broken cars when I was a student, and I had to have spanners and things so I could fix them. So I knew how they worked because I had to. But nowadays, they just work. You'd have to know how they work. Or if you want another example, microwave oven, right? Who's got a microwave? Who actually really knows what happens? It's magic, right? You put food in, it gets hot. That's all we know. Right. You put food with metal in, it explodes. Yeah. All right, that's okay. The two things you need to know about microwaves. Right. How do they work? Oh, radio waves. Yeah, right, magic, same thing. Right. Okay, so how black is the box depends who you're asking. So if we're asking for transparency, right, what kind of transparency do we want? Do we want the kind of transparency that a producer would need to understand how the rival technology is working and replicate it? Or do we need the transparency that a user needs, which is, I don't know, does the box work? When is it safe not to work it? When should you turn it off? When smoke comes out? Stuff like that. Right. And I mentioned different types of AI technology. And we also have to think about when we want transparency. Because if we want to know the things we want to know in advance, that's quite difficult to achieve with AI. Telling people in advance what the AI is going to do and how it's working is really quite hard. That can stifle a lot of useful AI technologies. It would, for example, stifle almost certainly the skin cancer recognition technology. Because if we had to explain in advance how it was recognizing skin cancers, we probably couldn't do it. Right. All we can do is to say, look, we have tested it, and it has a 90 whatever it is % success rate, and that's better than doctors. It's worth a go. Right. Now, what level of transparency is it? That's enough to make a user think, it's a good technology. Right? It's not enough to enable a producer to produce a rival technology. So asking what kind of explanation you want and when you want it is important. Yeah. Ex-post transparency is very different. Ex-post says, look, we used the AI, something went wrong. Can we find out how and why it went wrong? That's much easier to achieve. Right? And that, generally speaking, provides the explanations which existing laws need to allocate responsibility and liability. Right? Which leads me on to the question, if that's the case, can the existing law cope? Right? Well, if we think about that, we want to ask that question, maybe we should ask one question first. Okay, when do we actually want transparency? Do we want transparency for everything that involves an AI? Right? That's what the European Parliament Committee wants, but do we want it for everything? Right. For example, can we think of circumstances when we don't really care? Well, what if it's a really minor risk of compensatable loss? Maybe I'm not so bothered. And that's outweighed by the benefits to society. Yeah, I could live with no transparency if the risk to me is pretty minor and could be compensated, and there are lots of benefits to society. Here's a favorite example. No one's ever built one of these. It's a smart fridge. Right. The smart fridge uses the Internet of Things. It reads all the little chips in the stuff that you buy to eat. It orders new food for you, and it kind of manages your shopping for you. Right. One day someone will build one, be really clever technology. Right. What are the risks to me? Pretty small, I guess. How many people here have been injured by a fridge? No, it's okay. It's a fairly low-risk technology. Right. Can there be benefits to society? Potentially. You can see the fridge might be doing stuff like helping people manage medical conditions. It might do things like help you with have a better diet. Right. Simply by changing your ordering or even putting the stuff in different places in the fridge. Some colleagues have tried to say to me, no, the fridge is still dangerous. Right, the fridge is still dangerous. It could give you diabetes if it malfunctions and orders too many sugary drinks. To which my answer is, yeah, but I'm the one who has to drink them. I must have an element of responsibility over what I do with the fridge. And just because my fridge is offering me a high-fat, high-sugar diet doesn't mean I have to give in to the fridge. Right, one of us has to be in charge, and I think it might well be me. At least I hope it was me. Right. On the other hand, okay, when do we want ex-post transparency? Well, clearly, if there's a greater risk of loss, but is compensatable, and there are potential social benefits. Right? Now, at first sight, you think, well, self-driving cars fit into that kind of category. Because, okay, they're more dangerous than fridges. Everybody knows that. Right? But we already have a system for compensating people when they're injured in car accidents, and we have a lot of car accidents and a lot of injuries. So we know that system works reasonably well, and there are clear social benefits to introducing self-driving vehicles because of a lot less accidents. There are problems with that which are psychological. So we could say that will be fine, but I don't think we're going to. But what about autonomous drones? Now, autonomous drones are not just drones for kids to send off and get cool paparazzi photographs. Right. Autonomous drones are for things like investigating burnt-out buildings and crash sites and places that are too dangerous for people to go. Right. And there's a risk from letting this thing off on its own to fly on its own and do goodness knows what. But on the other hand, we can usually compensate people for losses, and there are clear benefits to society from doing it. So we'd certainly want to allow, I think, autonomous drones for that kind of purpose, but maybe not to allow them to appear outside your apartment block and start taking photographs of you. Right. So we may want to, but that's not regulating against AI, that's regulating against privacy intrusions. Right. We don't want people on a ladder taking photographs through your window. We don't want an autonomous drone. It's not the AI that's important, it's the photograph that we're worried about. And when do we want ex-ante transparency? Well, one of them is where there's a serious risk of fundamental rights breaches. Things like discrimination against people, things that are clearly unlawful, things like privacy breaches, because you can't put those right afterwards. And if you say, hey, we compensate you with a small payment, then actually you're letting people buy off your fundamental rights, and that means they're not fundamental anymore. They're now negotiable. They're part of the discussion. So if we have a concept of fundamental rights, then you can't be forced to hand them over in return for money. You can voluntarily do it, which we all do, by signing up to various social media sites, but you can't be forced to do it. And another reason that we're going to need ex-ante transparency is to convince society that the technology ought to be adopted. And I think that's the problem with self-driving cars, because I've asked the question in lots of conferences now, how do you feel about being killed by a self-driving car as opposed to a car being driven by a human? And the answer in 9 out of 10 has been we'd rather be killed by a human, even if it's more likely. Right. The one where it went the other way was the conference held at the Royal Society last November, full of scientists. They're all going, yes, okay, statistically cars are much safer if they're autonomous, so I'd rather be killed by an autonomous car. Right. So that's the statistician's answer, but the normal human's answer is no, I want better convincing. Right. But even then, think about the kind of transparency you want. Because in order to convince you to be happy about self-driving cars, do you need to know the detailed technical reasoning the car is using to drive? Right. What kind of transparency? You don't want that. You want a much higher level explanation of what's going on. And you probably are much more interested in how much testing did you do? In what circumstances did you test it? How well did it manage in testing? And there is a famous problem here called the trolley problem, which is that there's a railway line and there's a trolley on it, and it's coming down towards the points, and you can switch the points one way or the other. That way kills 6 children, that way kills 20 old age pensioners. You have the switch, you have to choose. And that, for some reason, has got into the minds of regulators. So it's now actually in the US regulatory recommendations for self-driving vehicles that this kind of trolley problem has to be explained. If the car is going to choose to kill somebody, it has to be able to explain to the regulator in advance how it's going to make that choice. Right? And yet, if you think about it, if you've ever been in an accident, let's hope it was a minor one, you weren't making choices about, who am I going to injure? You were making choices about what can I do next to try and make this less bad? Right? And I have a feeling that that's more the way that AIs are going to work, and they're not going to sit down saying, is it pensioners or children? How do I make the choice? It's not. That's an artificial question. That's not a kind of choice that's going on. Right? So, okay, what kind of transparency do you want? And then finally, can the current law cope? Because if the current law can cope for now, then that's probably good enough. We already heard Kim tell us, that the future is coming. We know that, but we don't quite know what it's going to look like. Right? And I'm aware of that. I was actually doing research on artificial intelligence and law back in the early 1980s. And at that point, the fully self-aware machine was reliably predicted to be 10 years away. And today, the fully self-aware machine is reliably predicted to be about 10 years away. Right. This is maybe the only field of technology where the future is much further away than you think. Or not. We don't know. But what we do know is over the next 2, 3, 4, 5 years, what's coming to us is much more limited stuff, the kind of stuff I've been talking about. So can the existing law cope? In the main, yes, it can. And the reason it can cope is because it doesn't regulate technology. It regulates humans. Right. I don't know of a single law that regulates technology. It may regulate how humans use technology, but it doesn't regulate technology. Right. And what it does is it puts responsibilities on humans. So to bring us back to interactive entertainment, if you're a game producer, you're going to owe contractual and negligence duties to the players who might suffer losses because of your game. Right. And that requires you to produce ex post explanations. Because if you can't explain how your game caused the injury, then a judge and jury is really going to work very hard to find a good reason to hold you responsible. If you can produce a good explanation, you might not end up with any liability. Humans who infringe fundamental rights have liability. So again, this incentivizes them not to do it. So they're going to be asking producers like Microsoft, how good is your... imagine that Microsoft produces a technology to help you make employment decisions. Right? The question any employer should be asking is, will it help me comply with my legal obligations, like not discriminating against women who are pregnant, and not discriminating against people on grounds of religion or race or whatever it might be? Because if it can't do that, I don't want it. And so in order to convince them, Microsoft has to give some kind of explanation in advance. Otherwise, people aren't going to buy the technology. So this liability might be enough for the next few years to keep us going. Right. I think most of the time we're going to get good enough incentives from our existing range of laws. And there are difficult edge cases. Self-driving cars are one of them, medical technology is another, and interestingly, they all fall in already regulated areas. So driving, you can't just build your own car and take it on the road. Right. Well, you can, but then you'll be arrested and you'll be charged with lots of criminal offenses and stuff, because there are rules about how to construct a safe car, and there are rules about having it insured and tested and stuff. So already driving is really heavily regulated. And again, if you look at the US system, which has done more work on this than most at the moment, the reason that it needs no law is because the law's already in place. There are licensing systems for allowing vehicles on the roads in states. There are National Transportation Safety Bureau recommendations to states about how they issue those licenses, and those licenses are now talking about AI. Right? No new law has been needed. We've used the existing regulatory system to deal with the problem. The same thing happens in medicine. Medicine is hugely regulated. It's a mixture of self-regulation and external regulation, and that is already looking at uses of machine learning and AI, and will modify itself quickly to deal with the problems. So I'd say that for the moment, we're reasonably safe. We're going to need to adapt existing regulation. Maybe in about 10 years' time, we might be looking at some comprehensive regulatory system. But I somehow doubt it. I can see why we regulate cars and aircraft and medicine, and I can see why we don't regulate fridges. And for games, I don't know. But in 5 or 10 years' time, we will know how to regulate them. I'm just not sure that all this fits within an overarching regulatory system called AI regulation. Right? In the same way that the attempt by the EU to put the whole world within an overarching thing called privacy regulation has been a pretty comprehensive failure. So, final words, in case you're with Mary Shelley, in case you're just thinking, yeah, but the singularity is round the corner and the human race is doomed, that's my final message.
Chris, thank you very much.
I ran over, I think.
Now, we're all going to coffee very shortly, but just before we go, Chris, we've obviously heard about the fact that we don't know quite when superintelligence is going to come around the corner. But what would persuade you that we needed comprehensive AI regulation? Clearly, you're that very unusual lawyer, a reluctant regulator. But at this point, what trigger would you envisage, if there was one, that would lead to comprehensive regulation?
Quite simply, I wish to be presented with a risk which is not easily captured within the existing legal and regulatory system. That's all. And not just a theoretical risk. Machines could become super intelligent and end the world, but someone like Kim coming along and saying, do you know, I've been doing some research on this, and actually, I think probably 2-3 years' time, we're going to have machines which will do exactly that. So, but I'd like to be presented a genuine risk.
Chris, thank you very much indeed. I think you'll agree this has been a fantastic start to the day. Great panel. Thank you very much indeed. Thank you very much indeed. Kim, Mike, and Chris, thank you.